My project is a sequence of 2 lessons with the goal of providing high school students with an introduction to polynomials in one variable that emphasizes polynomials as a system or a ring similar to the integers rather than functions. The first lesson focuses on definitions that emphasize the structural form of polynomials. The first lesson begins with a warm-up where students are asked to identify the differences between 2 sets of expressions, and the idea here is to get students to start thinking about the differences between polynomials and other expressions without knowing that they're doing so.
Hi everyone, we're going to begin today's class by going over some definitions, so please make sure that you're copying down everything that I write down on the board in your notebooks. So we're going to start with the definition of a term. A term is a number or variable by itself. So for example, we could have something like 3, which is clearly a number by itself. We could have something like x, which is clearly a variable by itself. Or we could have something like y, which is another variable by itself. A term can also be a product of numbers and variables. So some examples of this would be 3x, which is the product of 3, a number, and x, a variable. We could have something like 2x squared, which we can think of as 2 times x, which is the product of a number and some variables. We could also have something like xy, which is the product of 2 variables. So these are all examples of terms. Another definition we're going to be talking about today is the definition of a polynomial. So a polynomial is a group of 1 or more terms separated by addition and or subtraction. So some examples of polynomials are, we could do 3x squared plus 3. So we have 2 terms that are separated by addition, so this is a polynomial. We could do something like 3xy plus 7. Let's do minus 7 actually. So these are 2 terms separated by subtraction, so this is another polynomial. Another example of a polynomial is just the variable x. So a polynomial is a group of 1 or more terms. So 1 term by itself is a polynomial. Similarly, a polynomial, or 5 on its own, would also just be a polynomial. So a polynomial can have more than 1 variable. For example, this polynomial has the variables x and y. But in this class, we'll just be focusing on polynomials in 1 variable. So polynomials like this, polynomials like this. Technically, we can think of this as 5 times x to the power of 0. So this is also a polynomial in 1 variable. So when I say polynomial, I mean polynomial in 1 variable. So there are some rules about polynomials. Specifically, there are things that they cannot have. So firstly, a polynomial cannot have division by a variable. So for example, 5 divided by x cannot show up in a polynomial. The second thing that polynomials cannot have is variables raised to negative exponents. So an example would be y to the power of negative 2. This cannot show up in a polynomial. The third thing that they cannot have is anything raised to an exponent that contains a variable. So for example, 5 to the power of x cannot show up in a polynomial either. Polynomial can also not contain variables raised to an exponent that is not a whole number. So for example, y to the power of 2/3. And then lastly, polynomials cannot contain any variables under a root. So for example, the cube root of x cannot show up in a polynomial. So that means if an expression contains any of these 5 things, it is not a polynomial.
Next, the students will do a whiteboard activity that ensures that they understand the definition of a polynomial. I like these activities because they encourage all students to participate, especially the more quiet ones who aren't comfortable raising their hands. It also allows me to assess immediately for understanding.
We're going to go over a few more definitions. So the first definition that we're going to talk about is the degree of a polynomial. The degree of a polynomial in 1 variable is the largest exponent of that variable. So for example, if we have the polynomial 3x squared plus 2x minus 1, the largest exponent of the variable x is 2. So this polynomial has degree 2. Another example would be Let's do 5x cubed plus 7. The largest exponent of the variable x is 3, so we say that this polynomial has degree 3. And then one more example is the polynomial, let's say 6. So we can think about this as 6 times x to the 0. So the largest exponent of the variable x that shows up in this polynomial is 0. So we say that this polynomial has degree 0. So polynomials are given special names based on their degree. So we call a polynomial with degree 1 a linear polynomial. So an example of a linear polynomial would be something like 5y plus 7. So the largest exponent of y in this polynomial is 1, because we can think about this as y to the power of 1, and therefore this polynomial has degree 1, which makes it a linear polynomial. Another type of polynomial is a quadratic polynomial, and this is a polynomial with degree 2. So an example of this would be something like 3t squared plus 2t minus 4. The largest power of t that shows up in this polynomial is 2, so this is a quadratic polynomial. And then we also have what's called cubic polynomials, which are polynomials with degree 3. And an example of that would be 5a cubed plus 7a squared minus 3. So the largest exponent of a that shows up in this polynomial is 3, and so this is a polynomial with degree 3, and therefore a cubic polynomial. Polynomials with higher degrees also have names. We're only going to worry about these 3 types of polynomials for now.
Next, the students will do another whiteboard activity that ensures that they're able to identify the degree of a polynomial and classify a polynomial based on its degree, and also that they're able to identify the terms in a polynomial. The first lesson ends with a graded check for understanding. This is really more for my use to see where the students are having difficulty, and the questions are meant to ask the students to think a little bit deeper and really test whether they actually understand the definitions that we went over in this lesson. The second lesson explores adding and subtracting polynomials and alludes to the fact that polynomials are closed under addition and subtraction. The lesson will begin with a warm-up where the teacher plays a short clip of this comedy sketch where a man is making a fast food order, but basically he's just saying the same thing over and over again. So he asks for 3 burgers, then 2 fries, then has to take away 2 burgers, and so on. The idea is to get kids thinking about how we can say the same thing in fewer words, and we can apply that same idea to simplifying polynomials.
Hi everyone, we're going to begin today's class with a couple of definitions. So please make sure you're copying down everything that I write down on the board in your notebooks. So we're going to go over the definition of like terms. So like terms are terms that contain the same variable raised to the same power. So some examples are x squared and 2x squared. So these 2 terms have the same variable, which is x, and they're raised to the same power, which is 2. Another example would be let's do 2a and 1/2 a. So these 2 terms contain the same variable, which is a, and they're raised to the same power, which is 1. Another example is 5 and 7. So we can think about this as 5 times x to the 0 and 7 times x to the 0. So here we have the same variable, which is x, raised to the same power, which is 0, so these are like terms. Some examples of things that are not like terms are 2x and x squared. So these 2 terms contain the same variable, but they are not raised to the same power. So these are not like terms. Another example of something that is not a like term is 2x and let's do 3y. So even though these variables are raised to the same power, which is 1, these are not the same variable. We have an x and a y. So these are not like terms. We're going to take a look at this polynomial. So what I'm going to do is I'm going to circle all of my terms that contain an x squared. And I'm going to make sure to include the sign in front of the term. The next thing I'm going to do is I'm going to underline all of my terms containing x, making sure to include the sign in front of the term. And then I'm going to draw a box around all of my constants. So all of the terms that have the same shape associated with them are like terms. So for example, the terms with circles around them are the terms containing x squared, and these terms contain the same variable, which is x, raised to the same power, which is 2, so they're like terms. Similarly, 3x and 8x are like terms, and 7 and -4 are like terms. So we can think of this polynomial as containing a single x squared, because there's a 1 in front of this x squared. We can think of it as containing 3 x's, because of 3x. We can think of it as containing -2 x's, or -2x squareds. It also has 7 1s, 8 x's, and 4 -1s. So, like the man in the video from the warm-up that we did earlier, this polynomial is saying the same thing, or saying something in more words than it has to. So it's telling us how many x squareds it has 2 different times. So we can think about it like how the man in the video was said that he wanted burgers 2 different times. We can think of this x squared as burgers. So we're saying that we want 1 burger, and then we're saying that we're going to take away 2 burgers. Over here we're saying that we have 3 fries, and we want to add 8 fries. Here we're saying that we have 7 Cokes, and we want to take away 4 of them. Instead of saying all of that, we can combine the similar or the same items together. So for example, I can take all of the x squareds and lump them all together. So I have 1x squared here, I'm taking away 2x squareds over here, and that leaves me with -1x squared. Over here, I have 3 x's and I have 8 x's. If I lump them all together, I have 11 x's. And then lastly, I have 7 1s. I take away 4 of them. That leaves me with 3 1s, which is just 3. So this polynomial is exactly the same as this polynomial. It just says it in fewer words, or in this case, fewer terms. The process that we just did, where we lumped like terms together, is called combining like terms. And when all of the like terms in a polynomial have been combined, we say that the polynomial is in simplest form. So this polynomial is in simplest form because it has no more like terms. We've combined them all in the process of combining like terms.
Next, the students will do an activity involving polynomial cards, which are attached to the end of the lesson. So basically, they're going to be sorting the cards according to like terms, and once they've done that, they're going to combine the like terms in each pile. Here is an image of the polynomial cards that will be used for this activity.
All right, so now we're going to talk about adding polynomials. So we're going to do this problem. We're going to add the polynomials 4x to the power of 4 plus 3x squared plus 3 plus 2x, and the polynomial 2x cubed minus 3 minus 4x. So if I wanted to, I could put a 1 in front of these parentheses. And when I distribute that 1 to all of the terms using the distributive property, nothing changes, because when you multiply something by 1, you don't change that thing. So what I can do is distribute the 1 to all of my terms in both polynomials. And write the problem like this. So what this shows is that when I'm adding 2 polynomials, I can just get rid of the parentheses altogether. So now what I want to do is I want to write this polynomial in simplest form. So that means I don't want it to have any like terms, and in order to get rid of the like terms, I need to combine like terms. So what I'm going to do is draw a circle around all of the x raised to the power of 4 terms, and there's only one of them. I'm going to draw a box around all of my x squared terms, and again, there's only one of them. I'm going to underline all of my constants. I am going to draw a triangle around all of my x terms. And then I am going to draw a little cloud around all of my terms containing x cubed. And then I'm going to go ahead and combine my like terms. So my circle terms, the terms containing x to the power 4, there's only one of them, so I can leave that one alone. Similarly, my box terms, the terms containing x squareds, there's only one of them, so I can leave that term alone. My constants, so there's 2 of them, so I have 3, and then I have -3. I want to combine those, so +3 minus 3 is just 0, so I have a 0 here. And then I'm going to combine 2x and my -4x to get -2x. And I don't need to include this 0 here, so I'm just going to write my final answer like this.
The final answer should include a 2x cubed term, which I forgot to bring down from the second line.
I know that this is my final answer because this polynomial is in simplest form. And I know that because it has no more like terms. We've combined all of the like terms. The last thing we're going to talk about today is subtracting 2 polynomials. So I'm going to take the same polynomials as before, except this time I'm going to subtract this one from this one. So again, I'm going to draw an invisible 1 in front of the parentheses. And when I distribute this one to all of the terms in this polynomial using the distributive property, none of the terms change. But over here, I have to be careful because technically I'm distributing a -1 to all of my terms, which means that the sign of each term is going to change. So I just flipped the sign of each term in the original polynomial. So that shows that when you're subtracting 2 polynomials, you have to make sure, you can get rid of the parentheses, but you have to make sure that you switch the signs of the second polynomial. And then for the next step, we want to write this polynomial in simplest form. So in order to do that, we're going to combine like terms. So I'm going to go ahead and draw a circle around all of my terms containing x to the power of 4. I am going to underline all of my terms containing x to the power of 2. I am going to draw a box around all my constants. I'm going to draw a little cloud around my terms containing x. And I'm going to draw a triangle around my x cubed term. And then I'm going to go ahead and combine like terms. So I only have one term containing x raised to the power of 4, so I don't have to do anything with that term. Again, I only have one term containing x squared, so I don't have to do anything with that term. I have 2 terms that are just constants, so I can go ahead and combine those 2 terms. 3 plus 3 is just 6. I have 2 terms containing x's, so I'm going to go ahead and combine those. If I have 2 x's and I add to them 4 x's, I have 6 x's. And then lastly, I only have one term containing x cubed, so I'm just going to write that term. So this polynomial is in simplest form. I know that because there are no more like terms left to combine in this polynomial. So this is the final answer to this problem.
So this lesson ends with a graded check for understanding that asks students to subtract 2 polynomials, add 2 polynomials, and write their results in simplest form. It also gets them thinking about the idea that polynomials are closed under addition and subtraction.